Hey, so we're going to continue where we left off before, where I was talking about integer bases being raised to positive exponents or exponents to the 0 power. So I had, for example, 2 to the 3 was the same thing as saying 1 times 2 times 2 times 2, or simply just 8. Whereas 4 to the 0 power is 1 times, well, nothing, because there's no 4s, or simply just 1. And this was the case with all of the other numbers raised to the 0 power. They always equal 1. What happens now when we take and we raise something to the negative 3 power, for example? Well, we need to remember or remind ourselves what it means to be negative. Negative generally means to be the opposite. So instead of multiplying by 5, I am going to do the opposite. Well, what's the opposite of a multiplication? Opposite of a multiplication, in most cases, is a division. So I'm going to take 1 and I'm going to divide it by 5 3 times here. This is my exponent 3, and the opposite of multiply is divide. So I'm going to divide by 5. Well, it's the same thing as taking 1 and multiplying by a fifth, right? If we divide by 5, it's the same thing as multiplying by its fractional equivalent, 1/5. And so I want to do this with each one of these guys. And this is the same thing as, well, 1 times anything is always that same item, all over 5 times 5 times 5. And if we do our mathematics, we find out that that is over 125. It's the same thing as saying 1 over 5 to the third, positive third. So any negative exponent can be rewritten as simply 1 divided by the positive exponent. So another example of this, let's practice this a little bit more. 4 to the negative 2 is the same thing as saying 1 divided by 4 divided by 4, or it can be simply written as 1 over 4 times 1/4, or 1 over 16. This is the same thing as saying 4 over 2 to the second. These are all equivalent, and this will work with any number raised to any negative exponent